What up, guys? Welcome back, man. Welcome back to Herbs class for 5 more minutes of math. We can finish up this conversation on rate of change or slope, right? So usually slope comes around when we're talking about, yeah, exactly right, between 2 points on the graph. So let's get a graph up here and see what we're talking about. Okay, this is more like this. So I got a line and that line has a slope. Now slope is another way of saying steepness. Yeah, so when we talk about a rate of change for this line, what we're really talking about is the change in the height of the line. And you know our axes are y and x, so what we're really trying to find is this. Yeah, how much the y is changing versus how much the x is changing. Yeah, that's exactly right. So when we talk about rate of change with slope, we're talking about the rate of change of y compared to the rate of change of x. Yes, exactly right. Some of your teachers will refer to it as this. Yeah, rise over run. The change, remember delta means change. So the change in y is the change in height, which is rise, and the change in x is the change in run. Yeah, exactly right. Rise over run. So if I wanted to calculate the slope or the steepness of this line, this is how I would do it. First, starting at this bottom point, I would count how many spaces it takes to get up to the level of the other point. That would be the rise. Counting from here up to the level of my other point, since I'm going a positive direction, I would have a positive number, and that would be my rise. Let's say it was a number like this. Yeah, let's say it took 3 spaces for me to get from here up to this level. Then I would count the run. Yeah, once I'm on the level of that other point, I would just count the spaces to get to that other point. Let's say, for example, it might be 6 spaces to get over there. Yeah, so if I put my rise over my run, my change in y over my change in x, it would look like this. Yes, exactly right. And you know how to reduce fractions. That 3 over 6 changes into 1/2. That's exactly right. So the slope or steepness of this line will be 1/2. And what that means is for every space it goes up, it goes over 2. Yeah. Or I can think about it a different way. This 1/2 could be it goes up 1/2 space for every 1 that it goes over. Yeah, that's exactly right. And that's how you'll find it on the graph. Let's see a different example. Yeah, that's a good one. That's a good one. Now notice this line is not going uphill. This line's going downhill, right? We read from left to right, and so going from left to right, this line's going downhill. So let's talk about our rise over run. What is my rise? If I start at this point and I go down 4, shouldn't I show that? Yes, -4. So my rise is actually negative because I'm going down. Yeah. Now, for my run, I'm still going to the right, and that's still positive, so it's going to look like this. That's exactly right. The slope or steepness of this line is -4. It's going downhill, down 4 spaces for every 1 space it goes over. I know what you're thinking. Well, Mr. Herb, what if I started from this point? Good question. So if I started from this point, my rise, I would have to go up 4 spaces to get to that level. Good. But then I have to go left. So shouldn't that 1 be? Yes. And then that -1 goes. Yes. And when I do 4 divided by -1, don't I get the same thing? Yes. Exactly right. Exactly right. Exactly right. All right. Let me show you a different example.